Okay, so let us start. Uh, uh, I am Satyabrata Adhikari. I will take your two papers, MCS 230 Digital Image Processing and your MCS 231 Mobile Computing. So I have only six class to complete this module, and you have a strict schedules. So I may suggest you do not miss the classes, join the classes regularly, because the part we have discussed in this paper, most of the about 90% question you will get in the your coming exam. And the first paper, MCS 230, is digital image processing. Uh, in this model, we will discuss about what is digital image and why the need of a image is to be processed. Let us see. Please read the sentence. It is written here. Uh, are you agree with this sentence?
Yes, sir.
One picture is worth more than 10,000 words. So I agree with this sentence. That is, one picture actually is worth more than 10,000 words. That is, when you present something, your presentation contains some picture, or image, or graphics. It is easier for the students or the students to understand it. That is, one picture is worth more than 10,000 words. So pictorially or graphically representation of any presentation is more powerful, is more understandable. So as our model is image processing, digital image processing, so the first thing we must declare, what must discuss, what is an image is. Uh, Image is a representation of something or someone. The You may take example of any drawing, any painting, or any photograph. Anything which is a represents something uh, is known as your image. And it is, as you know, image are very powerful tool in communication. So it may be black and white or color in nature. So its color, it may be any color or a black and white color. You see there are two images. The first image is of a flower, which is in represented in a black and white color only, no other colors are there. But you view the you see the second image, which is also of a flower, but it is other colors, it is other than black and white. So a image can be any color or black and white. So then, uh, what is the digital image? Because we are processing a digital image here. What is a digital image? It is a representation of two-dimensional image uh, as a finite set of digital values called picture element or pixel. So when we represent an image in a computer screen, and it has two dimensional, it has two-dimensional value. That is, one is your picture elements and its value, a finite set of digital value, the first values, and another is the picture element or pixel. Uh, so it is nothing but it is a representation of a two-dimensional image. Why it is called two-dimensional image? You see here. So it contains two values, that is the position and the gray label values and the pixel value. Pixel is nothing but it is a stands for picture element, and you know that it is the smallest unit of an image in a computer screen. It is smallest unit. You cannot divide a pixel into smaller parts like a point. A point is a, you know that a point is a smallest unit of your graphic, your geometry. Suppose you draw a line. A line is nothing but it's a combination of some points, and a line can be divided into several points, but points can be divided further. So the point is a smallest unit in our geometry. Similarly, the pixel is the smallest unit of representation of an image in a computer screen. It is known as picture elements. So a digital image has two values. That is every pixel, which is the smallest unit, and the position of that pixel. And the position of that is why it is called a two-dimensional. You see the previous slides. It is a representation of a two-dimensional image. Two-dimensional means two values. Two values. What are those two values? The first value is the pixel itself, and gray label values, or second one is the position, where the position is. And you know that a computer screen is divided into x axis and y axis, so it has some positions. So pixel value typically represent gray labels, colors, height, and opacities, and the digitalization implies that a digital image of an approximation of a real screen. You see here, this is the mathematical representation of a digital image. When xy and fxy are finite discrete quantity, we call the digital image. That is, xy is nothing but it is the position of an image or of a pixel, and fxy is the pixel value of that position, or gray label value of that position, or intensity value of that positions. So that is why it is called your two-dimensional. That is xy is a position, fxy its value. So digital image is composed of finite number of elements, each of which has a particular location and value. So that is why it is two-dimensional. Every pixel has two values, one its location and its value. Value means its gray level value, its color value. What is the color of that pixel? So these elements are referred to picture elements, image elements. Sometimes it is known as pales, but widely known as pixels. So we are familiar with the word pixels. So pixel stands for picture elements. In some book it is written image elements. In some way it is pales, but more widely used pixels. You see here. As we discussed, a digital image is nothing but it is a two-dimensional representation of a two-dimensional thing. That is, it contains two values, xy and f of xy. Xy are the plane coordinate. You see here. You see the picture. Uh, you see there are two lines, one horizontal line, one is a vertical line, and there is a the vertical lines and the horizontal line are intersecting each other in a point. We'll take the first point. The first point is x0 y0. That is the position of that pixel. The pixel which is at x0 y0. X0 y0, it is known as the location of that picture pixel. Location of that pixel. X0 y0. You see that is the cross section, the intersection point of the line, vertical lines and the horizontal line. And a value at that point, a value at that point is known as f of x0 y0. That is the color value, intensity value, gray label value of that position. So every pixel have two values. You know that an image is nothing but it is combination of pixel, and every pixel has two values. One is its location, x0, y0, and another its intensity value. It is gray level values. In other words, simple word, you can call it is color value. What is the color of that pixel? So that is why every uh, image is dependent on two dimensional because it is two values. Are you getting?
Yes, sir.
Yes,
So
sir.
similarly, you see the second image. Its point is x1, y1. The value is the location is x1, y1. You see the intersection point that there is also two lines. One is horizontal lines, another is vertical lines. Their intersection point is x1, y1. It is called the location, and it's the intensity value of that point is f of x1, y1. You see where written is like a curve arrow. So f of x1, y1. So from this we know that it is clear that the summary of the class so far is that is an image is a two-dimensional function. It is a two-dimensional. That is a position, a location, and an intensity value, which is depended by here x0, y0, f of x0, y0. In second image, x1, y1, the location, and f of x1, y1 is the intensity value, gray level value, its color value. So an image can be classified based upon different criteria, different component. One is the attribute. You see here the attribute. You write your name and enrollment number in the board so that I will give you the attendance. So here the classification of image on the basis of attributes. The image can be classified by basis of various components. One is called the attribute. You see here vector. First is the vector image. The vector files are most useful when graphics need to be able to handle resizing. Are they written crispy detail when the scale to any size? So vector format is an excellent choice for digital illustration such as logos. So vector basically is used when you need some editing, that is from resizing. You want to increase or decrease the size of an image. So vector size is better. A vector file can be converted to a raster file. We will discuss about the raster file, but a vector file can be converted to the raster file, but it will the permanently lose the advantages of the vector format. So once it's converted to the raster file, there are various methods to convert this. We will discuss about that. But once it is converted to other form or raster file, it is permanently lost the advantages of the vector format. The advantage of vector format was you can resizing it. You can increase or decrease the size of one vector. The common vector size are extension are SVG, web-based vector format, EPS, Adobe-based vector format, and Microsoft Office-based vector format. So these are the some extension of vector files which can use for the vector image. Raster images are best for complex images like photographs and are more likely to be widely compatible file format such as JPG. JPG format, which are familiar with that format. However, raster image lost detail and become increasing blurry when enlarged. So you may see that when we increase the size of a raster file or your photograph, basically it is blurry when enlarged. When you enlarge it, it become blurry. That is not clear. Although a vector image can be saved as a raster image, it is not possible to convert raster image into a vector image. So you know that the vector file can be converted to the raster format. It lost its advantages of vector format, but can be converted. But the reverse is not true. The reverse means you cannot convert a raster file to a vector file. So raster file saved as a vector file format will still be a raster files. Most images of the web are raster files. That is, you if you increase it losses its brightness or it become blurry or not clear. So uh, these are the common raster file extension. JPG we are familiar with. PNG also we are familiar. Compressed raster format, other often used for photos, best for web use, small file size, compatible with most software. Most image on stock photography websites will be downloaded as JPG files. PNG format, the raster format good for illustration of icons, supported transparency unlike your JPG, best for web use, small file size. So these are the advantages of a raster file. Raster format that is best for high resolution printing, great for professional print use, especially when presenting piece image detailing important, large file size. That is when you make the file larger. So this is a TIFF form. You can take the printout of a large file, like your any professional printer use. So as we discussed, the image can be classified also basis upon other component. First one is attribute, and second, as you see, it is color. So based upon the color also, a, an image can be classified. A monochrome image are the image where the color component is absent. They are further classified into grayscale, which is also known as the grayscale or binary image. Why binary? It only represent, you know that the word binary means two. By means two. So binary image means it only an image when represented by only two colors, basically black and white. It is called a gray label image, grayscale image, binary image. So the term grayscale refers to the range of the shade between the white and black or vice versa. That is, if we change the proportion of white, that is combination of white and black. If we change the proportion, so it changes to basically the gray colors. So that is why the word gray label comes, grayscale image. That is why the grayscale image. So such image have many shades of gray and 8 bits. That is 2 to power 8 here. Uh, have you any question? Ask.
Sir, will we also discuss 3D images also?
Yes, 3D images are there, but actually here we have only in our course it is only the processing of a 2D image.
Okay, okay, sir.
Okay, so we have 3D object, 3D image, but here in the course only 2D images. So all the you see your syllabus, it is about a 3D, 2D image only. Okay. So such image have many shades of gray and 8 bit. That is, you see 2 to power 8. So mistakenly written 28. So it is 2 to power 8 and equal to 256 possible color. That is, we know, we tell only it is a black and white. Actually, the black and white binary color image is representation of a maximum 256 color. 256. That is different combination of white and black color. So maximum 2 to power 8, 256 are enough to represent the grayscale. That is, a gray image can be represented by 256 ways. So, but The human visual system cannot distinguish more than 32 different gate levels, and the additional bits are necessary to cover noise margin. Most medical images, such as you see the X-ray, I think you all see the X-ray images, CT images, MRI images. It does not contain any color other than black and white. Okay, so and sometimes it is gray colors. It's a combination of black and white. So the best example is any X-ray report. You see the X-ray report of any patient, CT image or CT scan image or MRI or ultrasound. These are the best example of grayscale image. It does not contain any other color. You will not find any red color, yellow color, pink color there. Only black and white and some of the gray color. Binary image. The binary image are just special case of grayscale where the process is thresholding is applied. We will discuss the thresholding because you will not understand thresholding in the first class. We will also discuss the thresholding method where the actually two colors is represent only black and white, no other color are there. Only black and white, no gray color are there. So that is why it is called a binary images. So binary image is a gray level image. It is a special case of that. But the color is only represented by two values, 0 and 1. That if it is white, it is 0, it is 1, it is black, whatever maybe. Okay. So that is only one bit is sufficient to represent the pixel value. But in previous case, we have discussed that a pixel value can be represent maximum 256 values, 0 to 255, 0 to 255, 256 values. But here, the binary image only represents two color only, especially two color, that is 0 and 1, either black and white. At that case, we can tell it is a binary image. So far we have discussed what is an image is, what is the digital image is, and the classification of images based upon color and based upon attribute. Digital image processing. Let us discuss digital image processing. Processing on image which are digital in nature by a digital computer. So when we process an image, process in the sense we may change its size, we may change its quality, we may change its pixel value, whatever may be. So are digital in nature in a digital computer. It is called digital processing, digital image processing. Suppose you draw a image in your copy and change it. It is not known digital image processing because your when you draw a picture in a copy, it is not digital image. So when you buy a digital computer, you are processing an image. That is known as digital image processing.
Excuse me, sir. I have a question. Hello.
Tell me.
Sir, what is the meaning of digital over here? If anybody is, drawing a picture in a particular system, then only it is called a digital, the image, or any image which is drawn in any computer system, that is called a digital.
So when when a image is drawn in a digital computer, suppose you are yes, you are suppose drawing a image in a computer, so it is called a digital image. And as we discussed, always it has two values.
That means any picture which has been drawn in the computer, that's called a digital, right?
Digital image. Yes.
Okay. Thank you.
Sir, what about those images if we draw it and then scan it on the system?
When you actually scan, so you cannot. There are some software you made to scan, process it.
So will that be called a digital image, sir?
Yes, you can tell.
Okay.
Okay, not only drawn. Don't know when can you represent that computer, digital computer. It is called a digital image. So then, what are the need? Why digital processing? Why digital image processing? That is improvement of pictorial information. That is, you after taking some picture, you found that that is the picture is not clear. Some pixel is missing. There are some gap between two pixels. The picture is not clear. Suppose you found that the some important information is missing from the pictures. And second, efficient storage of transmission. That is when you convert a analog image to digital image, it takes more space to store. Basically, analog image takes more space, and you can take transmission. You can also convert. There are some transmission techniques we can use only on digital image. So that is why the digital image processing is needed. Okay. You can improve the pictorial informations, and also you can store efficiently in your systems, which takes less space. Image processing. Image processing is a method to convert an image into digital form and perform some operation on it. So it is can convert it to a digital form. As you know that once it is converted to digital form, then you can perform any processing on it. So in order to get an enhanced image or extract some useful information from it, we need image processing. It is a type of signal dispensation in which input is image and output may be image or characteristics of associated with that image. That is, your output may be an image or any characteristic. Suppose there is an elephant. Suppose you take a picture of an element, but you are interested with some part. That is the only ear of the elephant. That is, you can also process that part only. Okay, not the entire part. So your output should be an any image or characteristics of associated with that image. It is among rapidly growing techniques today with its application in various aspects of a business. Image processing forms core resource are within engineering and computer science discipline too. So it is a nowadays it is a powerful tools, digital image processing. So as we already know, what is digital image processing? It is used to improvement of pictorial information for human interpretation. We already discussed processing of image data for storage, transmission, and representation of autonomous machine perception. So that is why we need a digital image and digital image processing for these purposes. It improve the pictorial information. Some argument about where image processing ends and fields such as image analysis and computer vision start. You see here. There are low level processing, middle level, and high level. In low level, input is image, output is image, and example only noise removal. Or image sharpening. This is noise removal, image sharpening. We will discuss about the later stage. What is how to remove the noise? What is the image sharpening? These are one topics. We will discuss about that. This is the process. But you see that if we remove the noise or we make the processing of image sharpening, it is belongs to low level processing. Middle level. Your input is image, but output is attributes. That is the attribute which are interested in. There are also two processes: object recognition and segmentation. We will also discuss what is object recognition and segmentation. So these two processes used for the middle level process. But when we are using scene understanding or autonomous navigation, it is belongs to high level processes. So here the detail of purpose of email processing. The purpose are observe the object that are not visible. As we discussed, if some picture is not clear, some pixel value is missing, some pixel value is spurious. So it is improve the object visualization. Image sharpening or restoration to create a better image. Image retrieval, seek for the image of interest. That is, you are not interested in the entire image, but you are only interested some part of the some part. Uh, so this is known as retrieval. You can retrieve that part, and you can get information from that part only, not from the entire image. Measurement of pattern. Measure various objects in an image. So different pattern are there, different attribute are there. You can measure it. Image recognition. Distinguish the object in an object. There are different type of object. You can distinguish it. Suppose you are searching for a flower in an image. How many flowers are there? Suppose you are searching a vehicles in an entire image. So this is image recognition. So we are interested in digital image processing. So the analog image is manipulated by the electrical means by varying the electrical signal. The common example includes the television image. But in digital image, it is help is manipulating of the digital image by using computers. The three general phases that are type of data have undergo while using the digital technique are pre-processing, enhancement of display, and information extraction. So these are the three steps we will discuss also. You see here. You see here, as you know that uh, T, you see here T, and the 0 represent the black color, and 1 represent the white. And this is a digitalization of T, the image T. You see the image T. So we can, when digitalize, so you see that is it is converted to its gray label values 0 and 1, where 0 represent the black color and 1 represent the white color. So as we know that is digital image means the computer views it as a number, as a value. You see, there are image, here's image. This is written as for human viewing. That is when you see the image. But in computer system, this is not an image. This is a representation of some values. You see here, some number are represented by that color. 56, 16, 57, 56, there are some color, there are some values. So when you view an image, this is the human viewing. But when you represent the computer view it by its number, its gray label values. As you know, the gray label value lies between 0 to 255, where 0 for the binary image, 0 is a black color, 1 is represent white color, but basically 0 stands for your black color and 255 stands for white color. And the other intermediate value is the combination of 0 and 1. 0 and
Sir,
255.
sir, sorry to interrupt you. Could you tell us again about the combination of these colors? Because in the computer system, as computer know only 0 and 1, right? So which kind of color is going inside the computer? Computer can understand only 0 and 1.
No, no.
Let's say
Hmm, hmm.
how computer can identify about the types of images, whether it is the analog, digital, and whatever the types of images, because computer know only 0 and 1.
Yes, yes. You see, that is, suppose you are writing a program. You are writing a program, na?
Yeah.
Suppose the computer know which language. Computer only
Binary.
understand one language, binary languages. So how can it done? You understand your Java language? There is a compiler, isn't it? Okay. But here you see that is when a represent a computer, when a image is represented, that is it is represent 0 to 255 colors. Okay, 0 to 255 colors. Here the idea of 0 and 1 doesn't come. Here a value of that images. So if there is a table, there is a table, from their tables it takes that values. That is, every image has a value which value store anywhere, and it is known to the computer. Okay, that is, every image has a value, and based upon that value it is dependent on the screen.
One the picture has been drawn in the system, then on that basis of value, it will be recognized about the type of the picture
Recognized by
image.
computer, recognized by the computer. Suppose you
Okay.
see here, you see, you see here. Suppose this color value, that is the pixel value, which is closer to 255. It is more brighter. Okay. And the pixel value which is closer to 0 is more darker.
Okay,
So
more clarity depends on the pixel size. If the pixel size is more, then the picture of the quality or clarity is more. Isn't it,
obviously,
sir?
obviously that is, yes, that is it will depend upon that pixel value. That is pixel value which is more darker. Suppose there are some the pixel value which is more darker. It is close to 0 because 0 represents the black color and 255 represents the white color. Suppose you have the pixel having value 250, and suppose you have another pixel value which is 10. So 10 is more darker than 250. Okay. Then digitalization. So as you know, uh, we need a digital image for processing. So how can an image digitalized? It will digitalize by two processes. One is sampling and another is quantization. So you see, image digitalization refer to the process of sampling and quantization of the analog signal which is required to convert analog signal to the digital form. So when you take a picture, and you will convert it to digital image. So we need two process. One is sampling, another is quantization. The digital image processing is performed using digitalizer, and the digitalization process consists of two steps. One is called sampling and other is quantization. Let us discuss what is the sampling and quantization is, because these two processes is important for converting an analog input to digital image. You see, sampling refers to the considering the image only at finite number of points. Each image sample is called the pixel. Okay, that is a simple word. You can tell sampling is associated with the location of the pixel. As you know, the pixel has two values. So sampling is used to find the location of the pixel, where the location is, where the position is. And quantization refer to the representation of the gray level values of sampling point using finite number of bits. For example, 256 level of quantization result in image storage for 8-bit process pixel. So quantization sampling is used to find the location of that pixel, and quantization is used to find the intensity value, gray level value of that pixel. Okay, so once you get the location and its gray level values, it is easily converted to a digital image. So when we capture an image of an object, we use image sensor to sense the incoming light and form the image. So image sensor convert the incoming light from an object into electrical signal that can be stored in a viewed later. So these analog signal are continuous and image are stored in the analog form. So when we capture an image, it is now stored in the analog form. We cannot process analog image by a computer. We already know we cannot process it. Analog computer cannot be processed. Analog signal contain infinite points and we need infinite memory to store them. As you know, the one need of the signal process is that is storage. In storage, it takes more memory to store. So and we need infinite memory to store them. An analog computer, we need to convert the analog image into digital image to store and process by a computer. So we need to convert the analog computer to digital image. Same thing written you. The analog computer is converted into digital image by digitaling the analog signal. We apply sampling method and quantization to the analog signal to convert them into digital form. So we need two methods. We'll discuss about the next slide. A digital image is formed by arranging pixel in the rows and column. Each pixel has a particular integral value. The computer processes that integral value and show that the pixel, the arrangement of the pixel from digital image. So same thing written as you see, sampling, digitalization is a coordinate value is sample are you discuss. Sampling means the coordinate value are associated with the position, associated with the location of that image, and quantization, digitalization is the amplitude value or the gray level values. So to convert the continuation image fxy into digital form, we have to sample the function in both coordinates and amplitude. So you see there is an analog signal. We have some sampling function to find the its location of each image, each pixel of that image. There are some sampling function how to find the location, but sampling is nothing but it is a process used to find the location of the pixel. For that purposes, various technique is used. Some function is used that is known as sampling function. And then the amplitude also, and by the method of quantization. And after get the two, you can draw the digital image. You see there's a corresponding digital image of that analog signal. So once it is sampled, so we need to quantization to get its amplitude value. So quantization digitalize the amplitude of the sample signal. Quantization is done by rounding of the amplitude of each sample and then assigning the different value according to the amplitude. Each value is represented different color tone. You see this picture. First, the analog signal are there. First, sampling to get the its location. then quantization to get his amplitude value, and after sampling and then quantization, we get a digital signal of the corresponding analog signal.
Sir, in this pictorial representation of images, what is the differences is coming? As we, if we are saying about the analog signals, then what is the, I mean, in analog signals, what could be the, I mean, the uh, differences, I mean, the fluctuation, I'm talking about the fluctuation. Analog में which kind of fluctuation is happening? बाकी जो अदर जो फिगर्स दिए हुए हैं उसमें जो हैं पिक्सल्स में क्या डिफरेंसेस आ रहा है?
एनालॉग कंप्यूट एनालॉग डिजिटल एनालॉग सिग्नल जो है, एनालॉग सिग्नल we cannot process it. When a system analog, we cannot process it. We have to convert to digital corresponding digital signal.
So analog signal cannot be processed. It could be converted into another signal. You mean
digital signal? Yes, digital signal. So it cannot be processed. Analog signal cannot be processed digitally. So
why?
Digital.
Excuse me, sir. Excuse me, sir. So why analog signal cannot be processed?
You see, because analog signal has the side is written. You see. You see, an analog signal contains infinite points. You see the second point. Infinite points.
Yes, sir.
And it is size is large. It's we cannot process it. It's infinite point. The size is large, and digitally it cannot be processed because it does not have any values. When we process it, we need some values like your digital processing.
Oh, okay, sir.
Okay, so so for digital processing, we need to convert to its which form? Digital form. So the process we are using digital processing cannot be used for analog signal because it does not have any. We need two things. When we processing it, we are going to change its pixel values. There are some values. It has some numbers, but analog signal does not have any numbers. You know that the system sees it by a number. The human sees it; it is an image, but the system sees it; it is a combination of numbers. Okay, so when we process it, that number is converted changed some other values to get better information. Or any?
Okay, sir.
So you may get some question in your exam, the difference between sampling and quantization.
Sir, why do we not get marks if we write sampling and quantization difference like this only? But they don't give marks, full marks for writing this much only. They want like, I don't know, they measure it by hand span or what?
Yes, you have to write by using a proper example, and you have to draw that images. Yeah, this is a simple idea about the sampling and quantization. What are the sampling and what is the quantization?
Okay, sir.
Okay, so this is a simple idea. That is, you will get something, and you are mature enough to write something extra. Determines the number of pixel of a digital image. So as you know, it determines the location, the position. So it determines the number of pixels, how many pixels are there in a digital image. Determine the tone of the pixels. Tone means the color value, the gray level values. Sampling digitization take a x-axis of an analog signal, but quantization digits the y-axis because you know that x-axis represents the location and y-axis represents the values. The amplitude value of the analog signal is recorded at a regular time interval. The amplitude value are rounded up at a given value. If it is some when you use the quantization function, if the function gives some value which is not which is a real number, which is some decimal points, is rounded to the nearest value. Done prior to quantization, done after the sampling. So these are the small idea between what is the difference between the sampling and quantization. And it is every processing from any converting from one signal to another signal. There are two processes used for that purpose. One is sampling, another is quantization, and these are the idea about what is the difference between them. Sometimes some error occurs when we converting. That is, the size of the pixel is important for image quality. The image quality, the size is important. But you know that your screen is the size of the screen is your mobile screen, your system screen is fixed. You cannot increase the size of your screen size. That is your it may be your cell phone size, screen size. It is already fixed. Your computer's screen size is already fixed. The size of the pixel is important for image quality. If the size is very large, then it will be lesser number of pixels. It is obviously that is as your screen size is fixed and you represent a digital image and the pixel size is large, it contains less number of pixels. So that if an image contains less number of pictures, less number of pixels, it become less clarity. It has less clarity. It becomes less, or which makes the image distracting and meaningless. This is called pixelation error, where the gray label discontinued at the edge of the pixel become poor. So if the pixel size is more or large, so you will get this type of error. So a question may arise in your mind that what about the standard size of the pixel? What is the standard size pixel so that it gives a good quality? It is known as, you see, it is written as the size of the pixel is large. The size is not mentioned here. Size is not mentioned. You do not tell what is the large size, what is the small size. But it is written that if the size is large, there will be lesser number of pixels. It is true. Because the screen is fixed and the pixel size is larger, it contains the less number of pixels. If the pixel size is less, it contains large number of pixels. That is the question arises that what should be the ideal size of the pixel? Should it be big or small? How do we decide that? The answer is Shannon-Nyquist theorem. There is a theorem, there is a technique used for that purpose. According to him, the sampling frequency should be greater than equal to 2 into f max, where f max is the highest frequency present in the image. You know that there are different frequency, different gray level values. Okay. And one pixel who has the highest frequency known as the 2f max here. Otherwise, the original signal cannot be reconstructed. Otherwise, the image has less quality. You see, take a good example here. What should be the physical size of a 2D image of a document with dimension 2400x2400 pixel when scanned at 300 dpi? 300 dpi dot per inch. Here, dpi stands for dots per inch. So the physical size of image is number of pixel in width by resolution and number of pixel in height by resolution. You see here the resolution is given. The physical size of image is 2400 into 300, 2400 into 300 at 8 inch into 8 inch. So if the physical size of the medical image is 8 inch and 8 inch and the sampling resolution is 5 cycle per mm, then how many pixels is required here? So this is the first, we need minimum, you see, 8 inch and 8 inch, the physical size. That is, your screen should be 8 inch to 8 inch to hold this type of pixel, which are the, you can tell it is an ideal size. You see, if the physical size of medical image is the second example is 8 into 8 inch and the sampling resolution is 5 cycle per mm, the how many pixels per cycle are required to have better quality image? Will an image of size 256 into 256 be enough? It is given that it is 5 cycle per mm, therefore for better quality 2 pixels per cycle are required. And you see here, so as you know, uh, the sampling theorem states that the sampling frequency should be greater than the twice of the maximum signal, and this means that 10 pixel per mm are required. So the pixel size is 0.11 mm. So the given size is 8 into 255 because 1 inch is equal to 254 2.54 centimeter. So it is need 2.32 plus 2.32 square centimeter. So therefore, we minimum number of required pixel is 2032, 2032. So an image of size 256, 250 is not enough. Okay, so here that is we minimum need 2032 into 2032, and so image
सर ये
size of 250.
सर ये 2
Sorry,
पिक्सल्स पर साइकिल कैसे आया सर?
no, 5 cycles per mm. For better
कैसे?
quality, 2 pixels. That is related 1 h, so maximum 2 pixels per cycles. Okay. So 5 cycle per mm है ना? So mm means 5 cycles. So for one 2 pixels per cycle, one cycle per 2 pixels.
10 हो गया,
Hmm.
10 पिक्सल्स पर एमएम हो गया।
Hmm.
ठीक है सर, नेक्स्ट स्लाइड में क्या है सर? 10 पिक्सल्स पर एमएम तो आपने लिखा है।
Hmm.
गॉट इट सर।
Okay. So maximum you need 2032 pixels. अच्छा image में take a few minutes break.
Sir,
I'll take
can
some.
we, sir,
हाँ बोलो.
sir, can we, I mean, this kind of a question can come in the exam. Can be
No, I
focused
got
in
actually
presentation?
I have taken.
Yes, it comes. I have seen
It may come.
last year.
Actually, that if you read these slides clearly, you may cover up to 70-80% questions. You may
सर ये स्लाइड कैसे मिलेगा मुझे? हमें दे दीजिएगा सर ये स्लाइड।
Sir, what you could do, we have a particular group for this kind of, the activities. Whether you are in that group or not, I am not sure.
No,
If
I
you are
am.
not, we will. Are you there, sir, in the group, in our MCS group?
No.
So, Kamal is the admin in our group. Right.
How would you share this, sir?
So on the group, I mean, in the group, sir,
You,
will share, na?
you may add me.
Okay.
Okay, you add me in that group. I will share this PPT. Otherwise, you can give your mail ID.
No, mail ID से sir क्या है? बहुत सारे लोग हैं. We have a particular group so that everybody
अच्छा
can get.
ठीक है. You add my number. My number is 9040109520.
एक second sir.
I am telling you 9040 109520.
9520. कमल इन नंबर में आपको
My
भेज
name.
दूंगा. आप ना सर को ग्रुप में ऐड कर दीजिएगा. 9040109520. ठीक है सर, डन. थैंक यू सर.
Okay, I will take 2-3 minutes break and I will then continue. Okay,
सर 10
thank you.
मिनट का ब्रेक ले लीजिए सर. 10
Please,
मिनट का ब्रेक ले लीजिए.
नहीं 10 मिनट नहीं, मैक्सिमम 5 minutes.
10 मिनट ज्यादा हो जाएगा संजय।
5 मिनट सर. ठीक है, डन. 5 मिनट.
ओके.
हेलो शशि,
Here.
कैसे हो भाई? कैसी चल रही है यार?
ऑल वेल भाई। अरे आपकी आवाज ही आ जाती है ना, जो एकदम, जो डॉल्बी स्टीरियो की आवाज है आपकी।
मैं आज
रियली,
मैं आज
यू हैव अ वेरी गुड वॉइस। यू हैव
अरे
अ वेरी गुड वॉइस।
मैं आज चुप बैठा हूँ। मैंने कहा यार, जब कोई मीनिंगफुल कोई सवाल आएगा तो मैं करूंगा, इसलिए मैं सबके सवाल सुन रहा हूँ। और मैंने कहा यार, देखता हूँ जब मेरा मौका
अरे
आएगा तभी
आपके
बोलूँ।
आपके ऊपर ये छोटे मोटे सवाल शोभा भी नहीं देते हैं। आप कुछ बड़ा बड़ा करने के लिए बने हो।
आज यार बहुत खुश कर दिया तुमने। सही है, सही है। संजय, संजय कैसे हो संजय?
बढ़िया भाई। मैंने वो सर वाला नंबर मैं ग्रुप में शेयर कर रहा हूँ, सो दैट कि कमल जो है ना ऐड कर देगा।
बिल्कुल
राइट।
बिल्कुल। कमल भी है ना अभी तो, इस टाइम मौजूद है ना कमल मेरे सामने?
कमल कोई नहीं, मैं कमल को ऐसे भेज भी दे रहा हूँ, रिकॉर्ड में रहेगा, जब भी
हाँ,
फुर्सत
नहीं
मिलेगा
नहीं,
ऐड
कमल है, दिख रहा है, कमल खिला हुआ है यहाँ पे, दिख रहा है।
कर।
कमल तो अभी खिला
कमल
हुआ था,
हमेशा
खिला
खिला ही
हुआ है
रहता
और
है यार।
खिला हुआ रहेगा।
कमल हमेशा खिला रहता है। अरे कमल जो है सबको जो है ना खिला के रखता है भाई।
हाँ, खिला के रखते हैं।
बहुत
सही
कमल
है।
मैंने ना नंबर दे दिया है आपको। कमल एक बार ना ऐड कर दीजिएगा, सर को अभी कर देना, सो दैट कि एंड ऑफ द सेशन ना वो पीपीटी हम लोग को मिल जाए।
कमल लग रहा है चाय पीने गया, वो बिल्कुल बोल नहीं रहा है ना कमल।
कोई नहीं, कमल ऐड कर देगा। और
तो
अच्छा, असाइनमेंट का कुछ डेट वेट बढ़ने का कुछ चांसेस है इस
यार
कोर्स
देखो,
नहीं
को
नहीं,
लेकर? हैं?
इस बार
टेक्निकली मुझे लगता है बढ़ गई है, लेकिन ये इतने आलसी लोग हैं, इन्होंने ऊपर तो डाल दिया कि नवंबर है, अंदर उसको क्लिक करके देखते हैं तो पीडीएफ में वही 31 अक्टूबर दिखाई दे रहा है। तो ये आलसी लोग हैं बहुत ज्यादा, इन्होंने अंदर का पीडीएफ नहीं चेंज करा है।
अच्छा, मतलब कर सकते हैं अभी।
हाँ, वो
नहीं नहीं
बढ़
हो।
जाता है, हर बार ही बढ़ जाता है।
हाँ, बढ़ता
ये
तो है हर बार।
पड़ता है। अरे
आगे
यार,
पीछे
एक बात
करके
बताओ,
30 नवंबर तक हर बार ही बढ़ जाता है।
सेकेंड थर्ड सेमेस्टर के इसके असाइनमेंट के मार्क्स आ गए या नहीं आ गए हैं किसी के थर्ड सेमेस्टर के?
आगे सब
हाँ,
आ गए।
मेरे थर्ड सेमेस्टर के आ गए हैं।
यार मेरे क्यों नहीं आए हैं?
मेरे तो सारे आ गए।
मैंने थर्ड सेमेस्टर में थर्ड और सेकंड के दोनों के एक साथ जमा करे थे मैंने।
अच्छा, एक चीज ना मुझे ना
यार
एक
आप
मेल आया
इतना
था।
ज्यादा ना लिख देते हो ना, इतना ज्यादा लिख देते हो कि उनको बहुत मुश्किल हो रही है तुम्हारा चेक करने में।
अच्छा शशि, एक बात बताओ, MCSL 229 का ना मेल एक आया था कि दिस असाइनमेंट इज नॉट सबमिटेड और इनकरेक्ट ऐसे करके। तो MCSL 229 कोई असाइनमेंट हम लोग का है? वो तो प्रैक्टिकल का था ना, जो सर
नहीं
ने
नहीं,
बोला था।
असाइनमेंट तो सबका है भाई। असाइनमेंट तो
नहीं नहीं,
सबका है।
MCSL जो है दैट इज नॉट ए पर्टिकुलर असाइनमेंट ना, वो तो प्रैक्टिकल में जो सर ने पढ़ाया था, तो बोला नहीं था कि वो बना करके ना मेल कर देना।
भाई असाइनमेंट अलग है, असाइनमेंट तो था ही।
नहीं,
असाइनमेंट?
असाइनमेंट जो है ना MCS से तो स्टार्ट होता है ना, असाइनमेंट
अरे
जितने भी कोड
एमसीएस
हैं।
भी होता है। एचआर के भाई
MCS
समझाइए।
अच्छा,
एचआर
समझा रहा
के
हूँ, समझा।
MCSL
देखो देखो
229 का भी है क्या?
हाँ, टू MCSL 22, देखो ये असाइनमेंट जो है ना,
हम्म
देखो हमारे पास जो थ्योरी वाले जो है पेपर, उनके MCS 224, 225, 226, 227, ये
हम्म
चार थे
हम्म
थर्ड सेमेस्टर में, ठीक है। इसके
हम्म।
अलावा वो जो है हमारे प्रैक्टिकल के असाइनमेंट है, जिसमें एल लगा होता है, MCSL 228, 229, ठीक
हाँ,
है। ये हमें टोटल मिला के हमें 6 असाइनमेंट जमा करने थे, 4 थ्योरी के, 2 प्रैक्टिकल के।
तो प्रैक्टिकल वाला जो था यार, वो भी उसको अपलोड करना था क्या हमारे वाले LMS
हाँ
हाँ
में,
जी
कि
भाई, हाँ जी।
सर को
हाँ
मेल पे
भाई
देना
भाई।
था?
अरे
सारे
यार,
असाइनमेंट करने हैं।
ये तो फर्स्ट
फर्स्ट
सेमेस्टर में
सेमेस्टर
भी
में
किया है।
एमसीएस 16-17 किया होगा ना आपने।
आप
हम्म।
भूल रहे हो,
नहीं,
आप
मैंने
भूल गए।
अपलोड किया है। अपलोड किया मैंने, मेल मुझे एक मिला कि दिस इज इनकरेक्ट, प्लीज अपलोड अगेन। मुझे फिर ऐसा लग रहा है कि प्रैक्टिकल वाला जो है ना, सर ने बोला था कि मुझे मेल कर देना बना करके।
ना 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 ना, वो
नहीं नहीं नहीं
मेल
नहीं
वेल करने का कोई
नहीं।
सिस्टम नहीं।
अरे मैं सारा का सारा उस पे होना, LMS पे करो उसे, अभी भी टाइम है तो कर दो उससे।
मुझे क्या
नहीं, मैं
लगता
कर
है ना,
देता हूँ आज।
उन्होंने गलती से जो सर क्लास वर्क वगैरह कुछ दिए होंगे करने के लिए, वो उन्होंने गलती से सबमिट कर दिया है।
अच्छा,
ये भी हो सकता है।
हाँ, इसी के लिए असाइनमेंट का ईमेल उन्हें भेज रहा है कि आप गलत सबमिट किए, क्योंकि सर जो क्लास में कराया वो तो हमें असाइनमेंट सबमिट नहीं करना है, वो क्लास के लिए है।
वो तो क्लास के लिए था।
हाँ, तो इसी
मैं
के लिए
चेक
लगता है
करता
उनको
हूँ
बता
आज।
रहा है गलत भेजे हैं।
संजय, आप जो है करो यार, इसको उस पे करो, LMS पे करो।
आज मैं उसको चेक करता हूँ, बिकॉज वैसे ये जो है ना, टाइम का थोड़ा सा इतना मारा मारी अभी चल रहा था कि मैं उसको ना
यार,
मेल बस देखा,
इंटेलिजेंट
फोन करा
बंदे हो,
नहीं।
इतनी बड़ी गलती कैसे कर सकते हो? कोई नया आदमी करे, तुम तो बढ़िया एकदम हीरो आदमी, तुम कैसे कर सकते हो?
आज चेक करेंगे इसको, हेल्प की
हाँ,
जरूरत होगी तो हेल्प मांगेंगे ग्रुप में।
अरे
प्लीज
यार
हेल्प
बिल्कुल,
अस, हेल्प मी।
बिल्कुल, 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 आधी रात तैयार है, कोई दिक्कत नहीं।
आधी रात नहीं यार, मैं 12 से पहले पहले ही बोल दूंगा कि क्या चाहिए।
वही 12 बजे रात की आधी रात हो जाती है। सही है, सही है। और
बहुत
बताओ।
मंथ बाद हम लोग सब मिल रहे हैं फिर से ऑनलाइन।
हाँ, ये अब कहते हैं ना 30 डेज है लास्ट के, फिर इसके बाद यम्मा यम्मा, और हम कहाँ और तुम कहाँ पता नहीं होंगे उसके बाद।
नहीं नहीं,
मेन
ऐसा
वो
सकते
एक
हैं।
प्रोजेक्ट वाला भी है ना यार, प्रोजेक्ट का वाइवा मेन है।
प्रोजेक्ट का
प्रोजेक्ट
वाइवा।
वाइवा, प्रोजेक्ट वाइवा कब होगा? एग्जाम के बाद।
एग्जाम के बाद।
मुझसे ये ODL वाला एक मेरा दोस्त पूछ रहा था कि यार पहले होगा एग्जाम, मैंने कहा यार मेरे हिसाब से तो बाद में होगा, मेरे हिसाब
नहीं,
से।
ओडीएल वालों का कभी भी हो सकता है भाई।
अच्छा, ODL वो इसी मंथ होने को है, ODL वालों का।
हाँ, हम लोग का जैसे जैसे वाइवा चल रहा है ना, वैसे ही वैसे होगा।
हाँ, हम
नहीं,
लोग।
ओडीएल वालों का भी सब एग्जाम के बाद ही होगा। वो 30 नवंबर तक डेट एक्सटेंड हो गया ना सबमिट करने को, तो उसके बाद ही वो कभी भी। और
हाँ,
दिसंबर फर्स्ट वीक से एग्जाम है, तो उसका भी अब एग्जाम के बाद ही, मैं मोस्ट प्रोबेबली मुझे लगता है जनवरी वगैरह में होगा।
सही बोल रहे हो।
हम लोग का तो फाइनल सेमेस्टर का एग्जाम जनवरी तक चल रहा है। इस बार बहुत फैला
हेलो,
सब्जेक्ट
क्यों,
दिए
दो
हैं।
ही पेपर तो है।
हेलो,
हेलो, हेलो।
गुड
हाँ
मॉर्निंग
बोलो।
सर।
गुड
वो
मॉर्निंग।
हाँ जी मैडम, बोलो बोलो आप।
वो जो क्वेश्चन पूछा था ना, 2 पिक्सल्स पर साइकिल,
हाँ,
वो उसका मैंने डाला है चैट पे, एक बार आप चेक करो।
ओके।
एनक्विस्ट फ्रीक्वेंसी ना, नाइक्विस्ट।
रिक्वेस्ट रेट से ही हम लोग निकाले ना, बिकॉज वी आर यूजिंग दैट फ्रीक्वेंसी ओनली फॉर कैलकुलेशन, इसलिए 2 पिक्सल्स पर साइकिल ले रहे हैं हम लोग, बिकॉज दैट इज अ स्टैंडर्ड आई थिंक।
is a special frequency for 1 cycle per 2 पिक्सल्स। अच्छा, नाइक्विस्ट जो है वो कहता है कि 2 पिक्सल्स पर साइकिल लेना चाहिए हमें, ठीक
हाँ
है।
हाँ, फॉर स्टैंडर्ड फ्रीक्वेंसी, अगर उससे लेस होगा तो लोअर फ्रीक्वेंसी, उससे हाई होगा तो हाई फ्रीक्वेंसी।
मतलब 2 साइकिल्स, तो इसलिए वो जो है मेरे ख्याल में 2 से मल्टीप्लाई कर दिया 5 को, वो 10
राइट
पर
राइट
साइकिल।
राइट राइट, क्योंकि हमें फाइंड आउट करना है पिक्सल्स नीडेड पर साइड।
तो ये हम लोगों ने अभी जो असाइनमेंट अगर बनाया है तो देखो ना, उसमें उसमें भी तो यही सेम
उसमें
सवाल दिया,
सेम क्वेश्चन है, सेम क्वेश्चन है।
सेम क्वेश्चन है ना।
हाँ, बस वैल्यूज डिफरेंट है।
वैल्यूज डिफरेंट, वैल्यूज तो
हाँ,
न्यूमेरिकल।
उसमें 4x4 है,
हम्म
इसमें 8x8 है आई बिलीव, और
हम्म
उसका भी 5
उसमें
पिक्सल्स पर mm है, और
उसमें
साइज 512 है।
उसमें 8 इंच बाय 6 इंच आया था ना आंसर उसका।
नहीं, अच्छा, आंसर
हाँ,
आप बोल रहे हैं क्या?
हाँ, वो लास्ट में जो आंसर आया था 8/6 आया था। 2400 बट्टे 2400, 2400 पिक्सल्स इंटू वो था।
हाँ, 3200 था, कुछ कुछ फिगर में डिफरेंस था, 2400 नहीं था असाइनमेंट में।
1016 पिक्सल्स पर साइड आया था, और
हम्म
हमने बोला था बिकॉज इट इज 1016, तो इमेज की जो 512 साइज है वो इनफ नहीं है, बिकॉज हमको वो पता करना है कि वो साइज इनफ है या
हम्म
नहीं उस क्वेश्चन में।
तो 2-3 बार ये क्वेश्चन करेंगे ना, अपने आप समझ में आ जाएगा, इतना मुश्किल तो है नहीं है।
हाँ हाँ हाँ,
नहीं, आसान है, ठीक है।
सिर्फ ये है कि प्रैक्टिस करने की देर है।
हाँ, वो थोड़ा सा लॉजिक समझ में आ गया तो इजी रहेगा।
हम्म। लेकिन यार ये बताओ, मेरा 3rd सेमेस्टर के असाइनमेंट्स का अभी तक मार्क्स क्यों नहीं भेजा है इन लोगों ने? ये नहीं समझ, किसी
सर
और का भी।
हमको सर
मेल
हमको
कर दो ना,
सारे
मेल कर दो।
असाइनमेंट के आ गए मार्क्स,
जी,
हमको
मेरे भी
सारे
सारे आ गए।
असाइनमेंट आ गए।
मेल करो,
हाँ,
मेल करो एचआर के।
मेल
हाँ,
किसको करें?
असाइनमेंट के लिए है एक
एक
स्पेसिफिक।
स्पेशल मेल है, स्पेसिफिक
हाँ
मेल है।
जरा बता देना अगर किसी को कोई नॉलेज हो तो।
हाँ,
सर
जरा
वो
चैट में भेज देना, तो मेरा भी एक फर्स्ट सेमेस्टर का असाइनमेंट
ग्रुप
बचा
में
हुआ
डाल
है।
दो ना, ग्रुप में डाल दो जिसके
उसमें
पास
है
वो ईमेल आईडी है।
एक आप गूगल सर्च कीजिएगा होम टू कांटेक्ट इग्नू, उसमें सारा लिस्ट आ जाएगा किस किस को किस किस पर्पस के लिए कांटेक्ट करना, वो ईमेल और फोन नंबर दोनों ही दे देगा, तो उसमें शायद आपको मिल जाएगा वो असाइनमेंट के लिए किस कांटेक्ट।
ईमेल आईडी
एक्चुअल
है
में
ना?
एक्चुअल में उसमें जब मैं एक और जो है इनका ना उसमें लॉगिन करके देख रहा, तो उसमें लगभग सारे असाइनमेंट जो है वो कह रहे हैं उसमें देखो एलएमएस पोर्टल पे, यानी कि उन्होंने भेज दिए हैं वहां से, लेकिन एलएमएस पोर्टल नहीं शो कर रहा है मेरे ख्याल में।
So will you start?
यस सर,
यस सर।
यस सर।
So image resolution. It means image resolution describe the image. Higher resolution means more image details. In digital imaging, the resolution is often measured as a pixel count, and a pixel, you know that it is a single point or smallest point or a tiny square in a graphic image stored in a order in a rectangular grid, and it is the smallest element in digital image. The resolution is defined as the number of pixels in a unit area. A unit area on the screen. Please switch off the audio. And as we discussed, it is the smallest element in digital image. It is the smallest element, the pixel. You heard about the megapixel, gigapixel, but the pixel is the smallest element. You see here, the resolution pixel count, the measurement is quantified for a specific unit of length. That is the number of pixels in a unit area is known as a pixels. The unit usually an inch, and the measurement is called pixel per inch, PPI, or DPI, dots per inch. Although DPI more accurately refers to the resolution of printing value, that is the image having higher pixel value is more clear, more quality. You see here different DPI, and the image having more DPI have a more or better quality. So after resolution, the second characteristics or second term which is associated with the image component is intensity. The term intensity refers to the amount of light or numerical value of a pixel. We have already discussed the intensity value, gray level values, and simply called color values, but it is the intensity value. It is a measure of energy of a wave which is directly proportional to the square of the amplitude of signals. From the point of view, the image processing, it is a numerical value which is a representative of a pixel. So, image processing point of view, it is an numerical value. It cannot be fraction. It is a new integer. It is not any real number. For example, for an 8-bit gray level image, the value of the pixel can be ranges from 0 to 255. We have already discussed. 0 stands for black color, and 255 represent the white color, and this is 0 and some numeric value and some intensity value. You can tell gray level values. Therefore, the higher the value of a pixel, whiter the pixel will appear. We have already discussed. That is, a pixel having higher value is more brighter or more whiter than the pixel having low value. In a grayscale image, intensity is depicted by the gray level value at each pixel. Two pixel with gray level value 127 and 220. Suppose there are two pixels and having two value. First one is 127 another is 220, then it can be interpreted by pixel the value 127 is more darker because it is closer to 0 as compared to 220. So that is why the 127 is darker than pixel with value 220. 220 is closer to 255.
Excuse me, sir.
Hmm.
Sir, we have two measuring units like pixel per inches and dot per inches, right?
Both are same.
Both are same. Means there is
Yes,
no
pixel per
specific.
inch is dot per inch. They are not two, that is one.
So we can use either. It doesn't bring any difference, right? So there is no difference between the two.
Hmm. Pixel per, you see, that is measured in pixel per inch or dot per inch. The pixel per inch sometimes refer as dot per inch. Okay, the
Okay.
pixel per inch, refer as dot per inch. They are not different. They are both are same.
So sir, if we are writing 72 pixels per inch or 72 dot per inch, it is same.
Both are same. Yes, both are
Oh,
same.
okay, sir. Fine. Thank you.
So this is your another thing. Dots per inch means that is the number of dots or number of pixel in an unit area of 1 inch. Suppose you take the length and breadth 1 inch both, and the number of area present that unit area is known as your pixel values.
Okay, sir.
So 127 is a darker because it is closer to 0, and 220 is a, obviously brighter because it is closer to 255. The tone constant is an image related to recording the differences in amplitude of the intensity at the surface of an object. So there are many ways in which contrast can be measured. It can be described as a product of the sensor signal contrast, depend upon the energy source and the physical property of the object. So this is another the detector constant. This depend upon the, so you know that this is the constant, which is another component. The constants basically is associated with the quality of an image. So the constant detector, there is a detector constant which depends on the way signal is detected, capture or store. In which way you detect the signals and capture and store, and based upon that component, the constant is determined. As you know, brightness is another component. It refers to the average pixel intensity of the image. Similar to constant, the image should be reasonably bright to show all the information to the viewer. The excessive brightness may affect the quality of image. So the picture has a limited brightness. If the brightness is more, it is also affect the quality. An image may have a higher brightness, but if the intensity is not optimal, the image again will not be exhibit good quality. So brightness resolution is defined as the number of identified distinct color, and it is also called the color resolution. So it is also an other component, other characteristics of image. And the another characteristics which we don't want in our image, noise. Noise is an unwanted disturbance that causes frustration in a picture value. So if noise is there, noise are different types. We'll discuss about in later side. Different type of noise are there, and different type of techniques, methods used to remove that noise. But you, for today, for the first class, you know that noise is an unwanted disturbance. We don't want to be present, the noise to be present in our image. So it is a random or stochastic process, and hence the true value cannot be predicted accurately. However, the noise obeys all the statistics properties. So we want to remove the noise from our images. So before go to the process of image processing, we must know what is a signal is. We all are know that the signal what is, but there is some uh, uh, revision, or we know how, what is your uh, signal. In a physical phenomenon that conveys or carries some information can be called a signal. A signal is anything you can see, hear, observe, or measuring using some machine. For example, speech is a signal because when you tell something, something will some signal will go to and you hear it. Something is suppose you there are some audio, also you can hear it because some signal reach your ear. Light also, radio, TV signal, radar, supersonic, temperature, ECG. So your EEG, all are the contain some signals. The information carried by the signal will be a function of independent variable. The independent variable can be time, spatial coordinate, intensity of colors, pressure, or temperature. But most thing is time. That the most popular independent variable in signal is time and is represented by t. Depending on the number of variable, the signal can be classified in one dimensional and multiple signals. A signal which is a function of a single independent variable is called one dimensional signal. But our image which are interested in, it is two dimensional. We know that. A music, speech, heartbeat, these are the example of one dimensional signal. A signal which has multiple values, more than two values, two or more values. It is known as multi-signal. A photograph is an example of two-dimensional signal. The photograph, the image, as we discussed, it is two-dimensional. So we are interested in the image processing. So an image is a two-dimensional signal. We know that it is a location and intensity. The motion picture of a black and white TV is an example of three-dimensional systems. Okay. One-dimensional function of t. Is an independent variable that is represent only one t. So a one-dimensional audio signal, such as the electrical signal or the output of a microphone, is a function of time. But you see, in two-dimensional 2D signal XY, which are interested, you see, the signal fxy is a function of two independent variables x and y, so that xy indicate the point in 2D space and f of xy depends on the intensity value. So our image is a 2D signal, two-dimensional signal, which contains two different values. The function f shows the intensity of a still image, and fxy represents the value of the intensity for the pixel of the function xy. So the important thing is that it is a two-dimensional signal. Our image when is considered as a two-dimensional signal. One is xy, another is f of xy. The intensity fxy and the location xy. So that is why our image is called a 2D signal. So a 2D signal represents a digital image where xy is the location of pixel and fxy is the value of the pixel. So a grayscale image is a discrete of 2D signal, xy and fxy. So a 2D signal can be of the various types such as separable and periodic, but it most important is it contains two things, xy and fxy, so that is why it is a 2D signal. Transformation. What do you mean by the word transformation? Can you tell what the word transformation mean?
So change.
Dictionary one, transformation. That is the change of one form to another. Okay, that is called transformation. Image transforms are necessary for image analysis and image processing. Transformation are mathematical functions that allow us to convert from one domain to another. Some domain are not familiar to us, not comfortable with us, so we can convert to another domain. So that is transformation. So a transformation of a signal fxy will convert to the signal into new signal, say gy. So a signal can be converted it to another signal in a different domain, because suppose some function or some work cannot be done in fxy, so we have to change to gxy in different domain. However, transformation does not change the information content present in signal imaging. It is important. Transformation does not change the information. If it change the information, so this transformation is useless. It does not change any information content, but only change to one form to another form. Let us see. You see a change in the program. Suppose you take the example of a number systems. You see x double I into x. X double I stands for 12 into x. If you do not change this to numerical system, we cannot multiply this. X double I cannot be multiplied by x. If you only give you x double I into x, but you don't know x double I stands for 12 and x stands for 10, you cannot tell the answer is 120. Okay. Suppose you will get in Roman form an answer. The question is x double I into x. So you know that the x double I is 12. So you transform this x double I from x double I to 12 and x to 10, and then multiply it, and it will tell that 120. So this is the need of transformation, because we cannot directly multiply x double I into x unless we know the value. So we convert the Roman form to the numerical form, to the Arabic numerical form, and then it is easy for us to multiply. Similarly, you see the second example. Longer integer form 12,000 into 15,000. So we convert it to the normal form, polynomial form, 12 into 10 to the power 3 plus 15 into 10 to the power 3. So you know that it is required to convert the normal form, scientific form, not only to for the easy of calculation, but also to store the computer system also, because you know that the computer store the floating point representation in floating point representation in a long integer. It first convert to the in normal form using some mantissa, some exponent. Please recall there are different methods to represent that form into polynomial form, scientific form, you can tell normal form, and then it is stored in the computer memory. So a large integer can be converted to that form, that is called transformation, for easy of store in computer memory. You see here. Intensity profiles. So it is a graphical representation in of an image, which are known as image processing. You can draw a corresponding graph by taking two axes. One is gray label values, another is pixel values. You see here the graph represents. I have written. You see, I have written there in my handwriting, that is B and W, and you see the image. The image contains white color, then black, then white, then black, repeatedly. And you see the image profile picture. It starts from the 0 and then gradually increases, reaches its highest value, white 255, and then decreases then decreases, reaches at B, black color, reaches at 0 and then increases. So you see first is a white, then black, then white, then black, then white and black also in image profile.
Actually, sir, highest is 255 or 256?
255.
255. Okay.
Because there are almost 256 color. It is ranges from 0 to 255.
Including 0, it is 256.
255. Okay. 256 different colors, but 0 to 255.
0 to 2. Okay.
So these profiles is very useful for image processing. So when we image processing, so it helps, the image profile helps uh, for different process of images, digital image processing. Spatial frequency. So as you know, the frequency used to rate the repetition of signal in spatial domain. But here we take two axes here, x-axis and y-axis. As you know, x-axis distance, you see the previous slide. The x-axis is the distance of pixels, and the y-axis is grade level values. So x-axis the distance of the pixels, and y-axis that location, and x-axis the gray level value the ranges from 0 to 255. Non-censoral method is so there are some different methods for image transforms. Some methods are Fourier transform, discrete Fourier transform, is known as orthogonal transformation. We don't have any non-censoral method which is very complex. An image is a 2D signal, so 2D transform is required to represent image in terms of discrete set of basic image. There are two forward and inverse transformation used. That is, as the name suggests, for forward and inverse transform. The forward transform means that is you converted from the original form to another domain for another form. And as the name suggests, inverse, that is we use inverse transformation to get the original form. Suppose A is the original form. After transformation, we change to form B and make some processing, made some addition, whatever editing, whatever maybe. And suppose after that you again want to convert the B to A to the original form. You need here the inverse transformation to get your image in the original form. Okay. So that is why two transform is required. One is forward, another is inverse transformation. You see, first is GUV, that is the summation of x goes for 0 to n minus 1 and y go to n minus 1, TUVXY into f of xy. That TUVXY nothing but it is a transformation function which is multiplied by fxy value. Okay, to get the GUV. So fxy is your original form. After using the TUVXY, the transform function, we get it GUV, which is a new form. And now you made some transform or processing. After that, you again want to return to the fxy. You see here, it is ixy that is you have to use the inverse function here. So t, you see the first equation t u v x y is there, but in second equation I x y u v is there, okay, which is applied to g u v, and you will get fxy which is originally there. In this way, the forward and inverse transformation works. Here T U V X Y and I X Y V is known as the forward and inverse transformation kernels functions respectively. Okay, so it is known as T U V kernel. Here is, you can tell it is a transformation functions, forward transformation functions and inverse transformation functions, which in transformation form is referred as kernels. It is not same as a Unix or Linux kernel. So transformation have some important property. You see, kernel is called separable. Sometimes the kernel is called separable if we use in forward transformation. That is TUVXY is equal to TUX into TVY. That is TUC. That is TUX and TVY. You see, that is U is applied to with X and V is applied, because in previous slide you see it is UVXY. We are, but in separable if we use in TUV and XY. Similarly, the kernel is called symmetric. The kernel is called symmetric if it is using T2UX and T2VY. That is U is associated with X and V is associated with Y.
Sir, what is the difference in these two, separable and symmetric? I can see only T1 and T2 difference, but no other difference.
You see. Oh. You see. The 2D signal can be of various types such as separable. You see the the last line of the first point. Okay. Separable and periodic. So separable here, which one? This one. Okay. If it is used, T1 and T2 are two different functions. But it takes the parameter U and X. That is, U is associated with X and V is associated with Y.
Sir, but in the second line, in symmetric, it is also the same.
In symmetric.
In symmetric, this is the same line as in separable.
No, there are two other functions, T1, T2.
Ah, yeah. The functions are different. T1 and T2.
The other two functions, the other T1, T2 is separable functions, and T2 is known as your symmetric functions. Okay. Separable is one type of transformation, and symmetric is another type of transformation. Okay. So T1, T2 are different two type of function. That is their function are different. So you see here. You see, we have an example. Now, example. Okay, so there are two different ones, T1 and T2. So it is separable and symmetric. There are two types of. Basically, you see, the first one, the separable, used in forward transformation, and the symmetric is used in inverse transformation. Got it or not? So please wait 1 minute. I take the. So have you written all your name and in the board?
Yes, sir.
Yes, sir.
Name, enrollment number we have.
Yes, sir.
Okay. So from this transformation, okay. So the example and other things we will discuss in the next class. So I will send you the PPT today. Please go through it, and you can ask me any issues or any doubts in the next class. I think it will be tomorrow, and so I have another class also on 11 a.m. So I will share
Tomorrow we
this.
have two, sir. Tomorrow we have two classes of yours.
One is in morning and
First
another is in
second.
the afternoon.
Ah,
Yes,
ah,
yes,
yes,
yes.
yes. So you can share this, the PPT in our group, sir. Kamal probably, added you in our group.
Yes, yes. I
We
will share
have a,
today. I will share. Okay, I will share today. Okay.
Yeah, once we go through the PPT, I think we can ask some intelligent questions tomorrow.
Okay, okay.
You are right.
Thank you, sir.
Thank you.
Can we
You
can
can
we
leave
can we
now.
leave the class? Yeah.
Yes,
Thank you,
can
sir.
leave now. Okay, thank you all.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
थैंक यू सर जी
Thank you.
क्या इसके कुछ मार्क्स मिलेंगे? ये जो हम लोग अटेंड कर रहे हैं, इसके भी किसी में मिलेंगे क्या कुछ मार्क्स?
इसके मार्क्स नहीं मिलते भाई
चलिए